Hi, eighth graders, welcome to Unit 4. In Unit 4, Part 1, we are reviewing prime factorization, which can be kind of tricky, so please make sure you take good notes. Before we get into actual prime factorization, we can look at just writing out factors. So for the first part, your directions are to write all the factors of the number. So if you remember, factors are numbers that go into another number, okay, or things that the number can be divided by. So we always want to start with 1. We're going to have 1 times the number itself, so 1 times 18. We ask ourselves if 2 can go in, so 2 times 9, 3 times 6, and then we're done there. So the factors are 1, 2, 3, 6, 9, and 18. Looking at number 2, we're going to start with 1, so 1 times 40, 2 times 20, 3 can't go into it, 4 times 10, 5 times 8, and then we're done there. So our factors are 1, 2, 4, 5, 8, 10, 20, and 40. And then for the third one, we're going to start with 1 times 41. 2 can't go into it, 3 can't go into it, 4 can't go into it. I think we're good there. So our factors are just 1 and 41. So after we're done writing factors, let's look at a few definitions. If you need to pause the video to write these down, feel free. First definition is a prime number. Prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So the smallest prime number is 2. Okay? 1 is neither prime nor composite because it only has 1 factor. So our smallest prime number would be 2. A composite number is a whole number that is greater than 1 and has more than 2 whole number factors. Okay? So our smallest composite number would be 4 because its factors are 1, 2, and 4. Prime factorization is when we write a number as a product of prime numbers. So if you don't remember what that is, we'll get to that in a second. And then a factor tree is a diagram used to write prime factorization. So factor trees you've probably been doing for a long time. And at this point, we use those to help us with prime factorization. So the next part just says to tell whether the number is prime or composite. So remember, a composite number is going to have 3 or more factors. So for 15, I know that 1 and 15 are both factors. I also know that 3 and 5 are factors. So that's going to be a composite number. For 13, the only factors are 1 and 13, which is the definition of a prime number. The only factors are 1 itself. For 25, I know it can be 1 times 25. It can also be 5 times 5. So 25 is a composite number. If you look at the next part, it says write the prime factorization of the number. So this is when we're going to get into using our factor trees. Sorry about that. Okay, so for prime factorization, we are going to start with a factor tree. So 32, I could break it into 2 and 16. I could break it into 4 and 8. I'm going to do 4 and 8. Then I need to break 4 into 2 and 2. The 8 I can break into 2 and 4. So this 4 needs to break into 2 and 2. Now a lot of people have trouble knowing when they're done with the factor tree. You're done with the factor tree when all of your bottom numbers are prime numbers. Again, prime being they can only have factors of 1 in themselves. So 2's prime, 2's prime, 2's prime, 2's prime, and 2's prime. So I'm done with my factor tree. Then I want to write out the multiplication, starting with the smallest number. In this case, I only have 2, so that makes life pretty easy. So I write out the multiplication. And then since I have 5 2's, I'm going to write it 2 to the 5th power. And I'm all done there. Looking at number 2, 56, I'm going to split that into 8 and 7. 7 is a prime number, so I can go ahead and circle that. 8 I can break into 4 and 2. 2 is a prime number, so I can circle that. And 4 I'm going to split into 2 and 2. I can circle both of those as a prime. Now I'm going to write out the multiplication, again starting with the smallest number. So that's 2 times 2 times 2 times 7. I have 3 2's, so I'm going to write that 2 to the 3rd times I only have 1 7, so I just write 7. That is the prime factorization for those 2 numbers. If you flip over to the back, there's some bigger examples. I'm going to save number 4 for you, but I'm going to walk through number 3. Again, when you get to bigger numbers like 180, there's going to be a lot of possibilities. I could do 10 and 18, I could do 20 and 9, I could do 2 and 90. A whole lot of possibilities of numbers that you could do. I'm going to go with 10 and 18. So 10 splits into 5 and 2. Those are both prime numbers. 18 splits into 2 and 9. 2 is a prime number. Then 9 breaks into 3 and 3. Those are both prime numbers. So now I write out multiplication starting with the smallest number. So that's 2 times 2 times 3 times 3 times 5. So that's going to be 2 squared times 3 squared times 5. And then that's going to be my final answer, my prime factorization. Now, just to illustrate that you can pick different numbers, so let's say I took 180, I broke it into 2 and 90. So I circle the 2 because that's prime. 90 I can break into 9 and 10. 9 I can break into 3 and 3. Those are both prime. 10 I can break into 5 and 2. So if you look, I would still get the same answer even if even if I picked different numbers to originally split it into. I would still wind up with the same prime factorization. Okay, so as long as you keep going until they're all prime numbers, you're good to go. All right, I'll let you guys go ahead and try number 4. All right, looking down, let me just clear off some space for myself. Okay. Next thing we're talking about is factoring a monomial. So as you can see here, a monomial is a number variable where the product of a number and one or more variables raise the whole number. So that's kind of confusing. Let me go over some examples of what would be a monomial and what would not be. Okay. So for instance, 4x squared y to the third is a monomial. Whereas if I had 4x squared plus y to the third, that's not a monomial. Okay. In the same way, if I had 16 a to the fourth b to the fifth, that is a monomial. Okay. But if I had 16 a to the fourth minus b to the fifth, that's not a monomial. So there's not going to be any operation signs in between them if it's going to be a monomial. It's all going to be one thing. Okay. So we're going to look at factoring a monomial. So when we do this, we want to start with the number part first. So I'm going to take the 8, and I'm going to do a factor tree just like I did before. So 8 is going to break into 4 and 2. 2 is prime, so I can circle it. 4 is going to break into 2 and 2. Those are both prime, so I circle. Now I'm going to write out the multiplication. So I have 2 times 2 times 2. And I also have to take into account my variables. So I have x and I have y. And we're just going to leave it like that. We leave it like this because it says to factor. It doesn't say to do prime factorization. I'm looking at number 2. Again, I start by writing out my number, which is 45. I split it into 9 and 5. 5 is prime, so I'm going to circle that. 9 splits into 3 and 3. Those are both prime, so I circle those. So again, I write out multiplication now. 3 times 3 times 5. And then I have 3 m's and an n, and I write all of those out. And then this is my factor of that one. All right, I'm going to leave number 3 for you guys. And then at the bottom, there are some review problems, which are just one-step equations. So they should be keeping short. That's it for Unit 4.1.